The final synthesizer module that I'd like to talk about in this segment is the LFO, or Low Frequency Oscillator. Like the envelope, it's a modulator, and its design is to control another parameter within the synthesizer. The envelope performed a specific shape every time a key was pressed. It was kind of started and continued on. The low frequency oscillator, though, is cyclic in nature. It will go up and down and up and down over and over. So it's great at representing things like vibrato. If you hear a singer sing, very often the pitch of that note will waver cyclically while it's being held. And an LFO is the perfect thing to apply that sort of variation. In fact, one of the main things that the LFO will modulate is the VCO, the voltage controlled oscillator. So your LFO is connected. You can think of it as wires being connected. The output of the LFO is connected to the VCO input, or the control input to the oscillator. So the pitch wavers. Now, every time you have a modulation, there's always going to be three things that you need to worry about. That's going to be the source of the modulation, this case the LFO, the destination of the modulation, this case the VCO, or the voltage controlled oscillator, and the amount of modulation. So you'll always have to set these things up. And in any synthesizer, there'll be a modulation matrix, or some way to say, okay, this modulator is controlling this parameter in this amount. Sometimes it's a field of, kind of looks like an Excel spreadsheet of different modulation sources, destinations, and amounts. Sometimes it's a drag and drop procedure. And sometimes, like in my basic synthesizer, the modulation is hardwired within the synthesizer. But that really is the complexity of synthesis, is how these modules are connected to each other. Now, an LFO has a couple of properties to itself. Like the voltage-controlled oscillator, it has wave shape. And the shapes are very similar. You have square waves and sine waves and sawtooths and possibly noise. But what's the difference between the oscillator and the LFO? The difference is the rate that they run at. An LFO is a low-frequency oscillator. And the term low is kind of nebulous, but what we're talking about in this time is lower than the range of human hearing. And we said that the low range of human hearing was 20 hertz. Well, an LFO is designed to run below that. So we can't really hear directly the output of the LFO. It's only useful in controlling something else. A typical range for an LFO to run at would be from 0 hertz, which we would call direct current, or DC, up to maybe around 100 hertz, maybe even a little higher. But what we usually use, the range we usually use it in, is going to be that 0 to 20 hertz range. And a typical vibrato of a human singer, or like a violin, is going to be in the 3 to 6 hertz range. So we'll always have to adjust that with our LFO. And usually there's an LFO controlling pitch, and that will be called vibrato. Now, vibrato is one of those terms whose meaning changes with context a little bit. When we're talking about a human singer, vibrato is a change in pitch, but it's also accompanied by a change in volume and a change in timbre that runs right with that variation. Now, in the simple synthesizer we're using in the screen movies, I have hardwired the LFO to control the oscillator only. But if I wanted, in a more complex synthesizer, to represent the amplitude variations and timbre variations of a real vibrato, I could have the same oscillator control the cutoff frequency of the filter, which would give me a little bit of those timbre variations, and I can have that oscillator control the amplitude of my VCA, or my voltage-controlled amplifier, to give those amplitude variations. So that's an important aspect of modulation in general, is that one modulation source can often control multiple destinations, which can open up lots of creative possibilities. So when we're looking at more complex synthesizers, what we really get are multiple pieces, are multiple versions of each one of these pieces. We'll have more than one oscillator, more than one filter, more than one LFO, an envelope. And we'll get multiple ways to connect them, more things we can modulate. But with these 5 objects, we really do understand the bulk of what's available to us in a synthesizer. Let's take a moment to look at the specifics of an LFO controlling the pitch of the VCO, or the voltage-controlled oscillator. An LFO, or low frequency oscillator, is an essential component of a synthesizer. Now, LFOs are general purpose devices that can be used to modulate a variety of things in a contemporary synthesizer, but one of the most important uses of an LFO is to create a vibrato effect. And a vibrato is a cyclic variation in pitch that's found in most musical performances. If you listen to a violin performance or a vocal performance, there are cyclic variations in pitch. It's part of the expression of the instrument, and we create that in a synthesizer by using an LFO to modulate the frequency of the oscillator. In some synthesizers, there will be a dedicated vibrato LFO, and in others, you'll have to configure the modulation yourself. Let's look at the aspects that are common in an LFO. When configuring modulation in any synthesizer, there'll always be a modulation source. In this instance, it's the LFO. A modulation destination. In this instance, it's the oscillator frequency. And there'll always be a modulation amount, which is going to be the extent of the modulation, which I have as a fader right here. For an LFO, we also have the typical oscillator parameters of frequency and shape. Amount is equivalent to the amplitude of the oscillator. In this synthesizer, the modulation source and destination are predetermined or hardwired into the synthesizer, but in your synth, you may have to configure that manually. In this synthesizer, we have a nice display for the LFO. This waveform display will show us a history of what the LFO is doing. Remember, this is not something we hear directly, but we hear its impact on the oscillator frequency. So I'll play a tone. Right now, the LFO is doing nothing because the LFO amount is all the way at 0. As I turn the LFO amount up, we'll start hearing the frequency of the main oscillator changing in response to the frequency LFO. So we're not hearing this LFO directly. This is not a waveform we are hearing. Instead, we're hearing this waveform's effect or modulation of the main oscillator, the audible oscillator's frequency. This is going up and down from the set point of the oscillator. If I change the amplitude, the extent of the modulation is further, so now the pitch is going up higher and lower for me. And if I increase the frequency of the LFO, we hear that modulation moves faster and slower. Now, like typical oscillators, we have a variety of wave shapes that we can use. So I am using a sine wave, but I can switch to triangle to get a more linear back and forth. And if I wanted to get something that was like a trill, I could use square wave and speed that up. And we get trill-like sounds. So we see that an LFO is not directly heard. In fact, the term LFO stands for low frequency oscillator, and the low really means below human hearing. These devices tend to move in the 0 to 20 hertz range, which is below the human hearing range, which starts at 20 hertz. Though LFOs can get up into the audible range at times, the typical usage is to have them moving much slower than that. In this synth, the LFO is hardwired or predetermined to control the frequency of the oscillator, but on most commercial synthesizers, the LFOs can be used to control a variety of parameters within the synthesizer. Now, I think the idea of an LFO is pretty straightforward and understandable. The challenge is going to be how to implement this in your synthesizer, because the hardest thing to figure out when learning a new synthesizer is how to configure the modulation. How do I establish the modulation source, the modulation destination, and the modulation amount, and possibly the modulation direction? On some synthesizers, this will be a modulation matrix of some sort. On others, it's a drag and drop procedure. Once you've figured out how to establish modulation within your synthesizer, you're going to have the hardest part figured out. So I'd like you to go to your synthesizer and figure out how to configure modulation. And you'll do it by configuring vibrato. Remember, all modulation requires a modulation source, a destination, and an amount. And the source will be your LFO, the destination will be your oscillator frequency, and the amount you'll configure in the synthesizer.